Hey crew, this is looking into exercise 11B, interpreting transition matrices. So far what we've looked into is being able to set up a transition matrix and understanding how to set it up and how to complete the matrix from a given network of some sort. What we'll be doing in this exercise, this one's a little bit of the calm before the storm. We're looking into interpreting that transition matrix and seeing what information that we can dissect from it. And then exercise 11C, which is in the next video, we'll be looking into being able to solve problems. Now 11C gets pretty in depth, so I say this with a bit of a warning. So looking into this one here, interpreting a transition matrix, here we have a particular matrix T, and its transition diagram can be used to describe, in this particular example, weekly patterns of rental car returns. 3 locations: Albury, Wodonga, and Benalla. Now, remember these, the one on the right hand side or left hand side, depending on where you write the label, is where it's returned to. So the cars that start in a particular spot will then get returned to another spot. And when you add the rows down, they should always add up to 1, like so. And this information here is effectively the same information here. So some people prefer interpreting the matrix because it's less cluttered, but other people like seeing this transition diagram here because it's a bit more visually intuitive. So there's no wrong or right way, they're both there up for offer in terms of using as a reference. So the first question here, what we'll be looking into is it's asking for interpreting the in-transition matrix and seeing if we can answer the following questions in terms of percentages. So what percentage of cars rented in Wodonga each week are predicted to be returned to both Albury, Benalla, and Wodonga? So we're trying to interpret this information now given the transition matrix. So for Albury, I accidentally put B and C, oops. So for Albury, and what we are doing is we're starting in Albury, or returning to Albury, sorry, from Wodonga. In this case, this is a 5%, okay? So 5%, we start at Wodonga and then we end up at Albury. So Wodonga here, when you rent this car, 5% of them go to Wodonga. We can see this, yeah, start at Wodonga, end at Albury, 5%. Not 50%, it is 0.05, so it's 5%. Second question is asking for it returning to Benalla from Wodonga, so this here is 15%. And Wodonga to itself, 80%. Now, generally speaking, it's not something you should rely on within a question, but just given in real life context, there's going to be a higher percentage or high weighting for the cars that are rented in the place that they started off at, returning to that same place. So you'll see this leading diagonal will be 70, 80, and 77% respectively. Pretty high weights in comparison. All right, so those are the answers for the first 3 for question A. Again, here's a reference for B and C. For question B, 200 cars were rented in the town of Albury within the week. How many of these cars do we expect to be returned to Albury, Benalla, and Wodonga? So they started at Albury, and we're finding percentage distributions for these 3 places. So in other words, if we start off in Albury, and we end in Albury, which is this one here, we're expecting 70% of those cars, which specifically is 200, to be returned back to Albury. So if 70% of 100 is 70, 70% of 200 is 140. So this is going to be 140 cars. For the second one, Benalla, this will be 10% rather. Benalla, Albury to Benalla. Sorry, 20%. Wodonga is 10%, 20%. So we're going to be looking for 20% of 200 cars So again, if 20% of 100 is 20, 20% of 200 is 40. So this will be 40 cars. And then the third one is that last 10%. Be 10% of 200, which is equal to 20 cars. Last question, question C. 160 cars were rented in Albury this week. How many of these cars are expected to be returned to either Benalla or Wodonga? And there's a key word here that says or. So we're going to be figuring out, there's two different ways that we can do this. We're either going to be figuring out if 70% is going to start at Albury and return to Albury, what that difference is for the remaining, or we can add the other two decimals together and turn them into percentage. You get the same answer. You'll end up getting 30% of what we're figuring out. The 70% is going to go to Albury. The other 30% is going to go to two other places, Wodonga and Benalla. So for question C, this case here, we're just working out 30% of the amount of cars to reach. What percentage? Oh, I'm figuring out question D. My bad. Percentage of cars are expected 100. Let's just work out question D. You know what? Let's go more wacky. There we go. Question D. I should have just checked it because I can see it on the sheet here as well. Question D is 30% of 168 cars. In this case, this is equal to 48 cars, so 0.3 times 168. Yeah, let's do question D first. Let's be weird. Question C. What percentage of cars rented in Benalla each week are not expected to be returned to Benalla? So if we are renting in Benalla and we return this to Benalla, the extra 2, which is 23%, won't be returned. So in this case, this is 23%. So this is either 100 take away 77 or 0.12 plus 0.11, which gives you 23. Either one will work. Cool. There you go. Question 11, questions 1, 3, 4 for exercise 11B, page 556. See you in the next video for 11C.